All right, in this video, I'm just going to talk about how to evaluate definite intervals using limits, and this is a continuation of section 5.2 dealing with definite intervals. We know that if f is integrable on the interval ab, then the interval from a to b of f of x dx will be this. The limit as delta approaches 0 of the summation for k equaling from 1 to n of f of x star sub k times delta x sub k, and that's for any partition of the interval AB and any points x star sub k. Now, to simplify these calculations, we use equally spaced grid points and right Riemann sums. That is, for any value of n, we let delta x sub k be equal to delta x, which will be b minus a divided by n. X star sub k will be equaling to a plus k times delta x, a plus k delta x, I should say, for k equaling from 1 to n. Then, as needed, as n approaches infinity, and delta will approach 0. So here's what we have here. The integral from a to b of f of x dx equaling to the limit as delta approaches 0 of the summation for k equaling from 1 to n of f of x star sub k times delta x. That would be the limit as n approaches infinity of the summation for k equaling from 1 to n of f of a plus k delta x multiplied by delta x. Okay, so we're going to use definitions of limits using these limits here to find this, the integral from 0 to 5 of x squared minus 5 dx. Now here in this problem they give the setup for it, and then you have to simplify this out. Alright, so here's what we got, and I'm going to do this on a separate sheet of paper. I might need 2 sheets with what I'm going to do, how I'm going to work this problem out. So here we got the integral from 0 to 5 of x squared minus 5 dx. Alright, so now we have our lower and our upper limits here. So we have a equaling to 0 and b equaling to 5. So that means that delta x, that we know is b minus a divided by n. Here b is 5 minus a is 0 divided by n. This will be 5 over n for our delta x. Okay. And then, I'm going to bring this down a bit. We're going to use this notation right here. Okay. So this right here is represented by the limit as n approaches infinity of the summation for k equaling from 1 to n of f of a plus k times delta x, that's multiplied by delta x. Okay, that's what we're going to use here. So now let's do our substitution here. Bring down the limit as n approaches infinity of the summation for k equaling from 1 to n of f of, our a is 0. K is going to be delta, well, bring down the k. Delta x is 5n, so it'll be k times 5 over n. Times delta x, that's again 5 over n. And what I'm going to do is simplify this here. I'll limit as n approaches infinity. And notice I'm going to continue to bring this notation down on each line. Well, if I simplify 0 plus k times 5 over n, this will be 5k over n. So it'll be f of 5k over n. And that's going to be multiplied by delta x, which is 5 over n. Now, in this case here, f of 5k over n, my f of x is this right here, x squared minus 5. So let me write this off to the side. F of x is equal to x squared minus 5. So when I replace that x with that 5k over n, this x will be 5k over n, and that's squared minus 5. Okay. So now I got the limit as n approaches infinity of the summation for k equaling from 1 to n of, and in this case, f of 5k over n is this. And I'll put this in brackets. 5k over n, and that's squared, minus 5 times 5 over n. Now, if we look back to this right here, they give you a setup to choose from. So in this case here, this right here is the same as this one. I got the limit as n approaches infinity of the summation for k equaling from 1 to n of 5k over n, and that's squared, minus 5 times that 5 over n. So I can go ahead and select this as my answer choice. That's the setup. Now, we have to evaluate this. So we take this a little bit, we'll just take this a little bit further, I should say. Bring down the limit as n approaches infinity of the summation from k equaling to 1 to n of, let's see what we can do inside this bracket here. If I square 5k over n, 5k and u squared would be 25k squared over n, and u squared would be n squared, then minus 5. And then that's going to be multiplied by 5 over n. All right, so now for the next line, limit as n approaches infinity of the summation of k equaling from 1 to n. If I distribute this 5 over n over the 25k squared over n squared and the minus 5, here's what I'm going to have. 25k squared over n times 5 over n. Well, 5 times the 25, that would be 125k squared. N squared times n would be n cubed. Minus 5 over 1 times 5 over n would be, well, 5 times 5, that's 25 over n. Okay. So all I did there was distribute the 5n over 25k over n squared minus 5. Now here's what I'm going to do here. Since I have the summation of the difference, I can write this as a difference of their individual summations here. So I'm going to bring down the limit as n approaches infinity of, and I'm going to write this as two separate summations. The summation from k equal 1 to n of 125k squared over n cubed minus the summation from k equaling from 1 to n of 25 over n. Okay. Then we bring this down. Now that 125 over n cubed, I'm dealing with just k in this case, so I can pull this out on the outside as 125 n cubed times the summation for k equaling from 1 to n of just k squared minus And I'll pull the 25 over n on the outside as well. And that'd be multiplied by the summation from k equaling to 1 to n of just 1. Now I'm going to use those rules from section 5.1 that deal with the summation of powers. This k squared, if you have the summation from k equaling to 1 to n of k squared, that would be this: n times n plus 1 times the quantity 2n plus 1 all over 2. And I'm also going to use this, the summation from k is equal to 1 to n of some constant c. It'll be the constant times whatever n is, or that upper limit. So here's what I'm going to do on the next line. Limit as n approaches infinity of, I'm going to bring down that 125 over n cubed, and replace this, the summation from k equal 1 to n of k squared, that's going to be this right here. N times the quantity n plus 1 times the quantity 2n plus 1, all that's over 2. Then minus, bring over that 25 over n, the summation for k equaling from 1 to n of 1, I'm going to use this rule right here, 1 times whatever n is. But 1 times n is n. All right, next line would be this, the limit as n approaches infinity of, now I'm going to bring down that 125 over n cubed, and I'm going to multiply this out. For n times n plus 1, I'm going to distribute the n over the n plus 1 to get n squared plus n times 2n plus 1 all over 2 minus, and in this case 25 over n times n, these n's divide out. I'm left with just 25. Okay. Now I'm going to simplify this some more in the bracket. So I have the limit as n approaches infinity of 125 over n cubed. If I multiply this out, for this out, this will be n squared times 2n. That'll be 2n cubed. And then n squared times the 1 would be plus n squared. Plus n times 2n, that'll be 2n squared. Plus n times the 1 would be n. All that's divided by 2. And then minus 25. And did I mess up somewhere? This should be, oh no, yeah, I see where I messed up. That should be over 6. The n times n plus 1 all divided by 2, that should be over 6. Okay, might want to refer back to that video for section 5-1, or part 2 of that video. Okay, so this should be a 6 here, a 6 here, and a 6 here. My apologies. So now the limit as n approaches infinity of, let's see here, 125 over n cubed times 2n cubed. N squared plus 2n squared is 3n squared plus n divided by 6, and then minus 25. And I'm going to break this up by putting each term over 6. So here I got the limit as n approaches infinity of, and I'm going to bring down this 125 over n cubed times, that 2n cubed will be over 6, plus 3n squared will be over 6, plus n would be over 6, then minus 25. So the limit as n approaches infinity of, if I distribute that 125 over n cubed over these three terms here, so 125 over n cubed times 2n cubed over 6. These n cubes are going to divide out. So that means I'm going to have like 250 over 6. 125 times 2, that's 250 over 6. Plus 125 over n cubed times 3n squared over 6. Well, one of the n's will divide, well, two of the n's will divide out, leaving me with an n in the denominator. 125 times 3 will be 375, and I'll have a 6n in the denominator as well. Okay? So n times that 6, that'll be 6n. And then plus 125 over n cubed times n over 6. Well, an n will divide out with the n cubed, leaving me with n squared in the denominator. So I have 6n squared over 125. And then minus 25. All right. Let's see if I can reduce this here. 250 over 6 will be 125 over 3 in simplest form. Divide the numerator and the denominator by 2. Plus, if I divide 3 into 375, I'm going to have 125 over 2n. 3 goes into 6 2 times. And this will still have to be 125 over 6n squared minus 25. Now, of course, the limit of the sum and the difference will be the sum and the difference of the individual limits here. So here's what I'm going to have. The limit as n approaches infinity of 125 over 3 plus the limit as n approaches infinity of 125 over 2n plus the limit as n approaches infinity of 125 over 6n squared minus the limit as n approaches infinity of 25. I'm just taking each of these and taking the limits of each of those individual terms here. Okay, so now I need to continue this on the next page. Okay, now I'm going to bring this down. 125 over 3. I can pull the constant out in front of the limit, so it'll be 125 over 2 times the limit as n approaches infinity of 1 over n plus the 125 over 6, I can pull that out in front, be 125 over 6 times the limit as n approaches infinity of 1 over n squared minus the limit as n approaches infinity of 25. I know something else here. I know the limit of any constant will be a constant. So the limit as n approaches infinity of 125 over 3 would be 125 over 3. Now, as we let n approach infinity, 1 over n is going to be going to 0. And the same holds true for as we let n approach infinity, 1 over n squared. That too will be going to 0. So that means I'm going to have 0 times 125 over 2, that's 0, plus 0 times 125 over 6, that's also 0. And then minus the limit of a constant is a constant, so the limit as n approaches infinity of 25 will be 25. So I got 125 over 3 minus 25 over 1. And of course, the common denominator for 3 and 1, that's going to be 3. So 3 goes into itself one time, that's 125. 1 goes into 3 times. 3 times 25 will be 75. So if I subtract 75 over 3 from 125 over 3, I will end up with 50 over 3. And that would be the limit, that would be the integral from 0 to 5 of x squared minus 5 dx using limits for definite integrals here. Okay. All right. So go over this video as much as you need to. This is just an example of how we evaluate definite integrals using limits. And that's the continuation of section 5.1. I mean 5.2.